Hello and welcome to Unit 4 of Block 1 of MPC005 Research Methods, first year IGNOU MA Psychology subject. So I am Kavya and I am taking this class with the idea that this will be useful for someone who is attending the exams. So we will be looking at all the topics from this chapter from an exam point of view, and here we will be focusing on the different topics which have come in the past exams, and we'll also be having this discussion only in English so that we can easily remember all these points when you have to write it in the exam. And we'll be using very simple English and we'll be explaining the concepts here so that it is easy to understand the text material before you try to learn and memorize it. Also, this will be helpful for you to understand and read the textbook faster. So as always, please keep the textbook with you so that it is easier for you, textbook or the PDF copy of the text material, so that it is easy for you to understand the concepts that we are discussing here. So our topic is hypothesis formulation and sampling. This is slightly longer chapter because both hypothesis and sampling both have a lot of concepts in them, and both these have been repeatedly asked during the exams. So hypothesis, as we already know, is a mechanism of knowledge, and it's a tentative explanation. It's a potential answer to a solution. Okay, so hypothesis is like the first step of a scientific research process. We are trying to make a statement, or we are trying to give an answer or a solution to a problem using the hypothesis. So it is considered as a tentative and testable statement showing the relationship between the cause and the effect. And here in the text we have been given certain definitions by certain psychologists, so I'm not going into that. You may read these. So a good hypothesis meets certain criteria. So that is important because meaning and characteristics of hypothesis have been repeatedly asked for the exam. So hypothesis should be clear conceptually. That is, whatever you're giving as a hypothesis, it should be clear. For example, we are giving a hypothesis that brushing our teeth will reduce cavities. So that concept should be very clear. It should be testable. So testable as in we should be able to test if somebody is doing brushing and for how long do they do it, how many times in a day they do the brushing, and then we should be able to, that is the cause or the independent variable, and then we should be able to see the response or the dependent variable, that is if there are cavities in the teeth. So that should be testable. Hypothesis should be related to an existing body of theory. That is, hypothesis you cannot make a new hypothesis just without any background knowledge. We should have some background knowledge about the subject, some theory. So some reading and review of literature is needed. So it has to be related to some past knowledge. It should be logically unit, and it should be comprehensive. It should be verifiable. That is, somebody else should be able to see if whatever hypothesis we have made, if it is right or wrong. It should be operationalizable, which means we should be able to make some relationship in the hypothesis. We should be able to, so in the last chapter we are talking about variables. So number of times you brush in a day, that is an independent variable. Duration of brushing in a day, so that is an independent variable. And number of cavities, that's a dependent variable. And now there is a concept that brushing will actually reduce cavities. The construct is there. So you can say some construct you can develop in this case, so that whatever construct the research is developing, that should be operationalizable in terms of the independent dependent variables. So all of these are the characteristics of a hypothesis. So before we make a hypothesis, while we formulate a hypothesis, the researcher should know that the hypothesis should be logical, testable, verifiable, all the characteristics we say, so that it can be replicated and verified by another researcher if they know that such and such a thing is being investigated. So it always is very important for us to have a clear idea and vision about the hypothesis. so that we can avoid difficulties, so that we can avoid situations where we end up making wrong or bad hypothesis. So the next topic is possible difficulties in formulation of a good hypothesis. This is also a repeatedly asked question. So what are the difficulties in formulating a good hypothesis? We already know what is hypothesis and what are the characteristics of good hypothesis. Now to understand what are the difficulties, we have to avoid certain issues which so that the characteristics of a good hypothesis is maintained. So there are three major difficulties. First is absence of knowledge, absence of past knowledge. Second is absence of knowledge of a theoretical framework. Third is when investigator is not aware of the scientific research techniques. That is, in the first case, if there is absence of knowledge of theoretical framework, that is, if we even don't have any idea of connecting the theory and the independent and dependent variables, then it is difficult to make hypothesis. So before we make a research hypothesis or before we plan a research design, the researcher should know how to connect, how to make a research framework so that we can connect independent and dependent variables. Second is they should have some literature review. They should learn or understand or read what past theories are there. So lack of that knowledge, lack of knowledge on past evidences will make it difficult. And third is if we don't know the right tools, what tests need to be done, what methods need to be employed to get the data. All these three are important. So hypothesis is always derived from a problem statement. So when we are talking about the research steps of doing a research, we're saying the first step is identify the problem, then go to the variables, all of those. So in the when we make a problem, then we have to derive a hypothesis out of it. So it's only from this problem statement we can derive a hypothesis, and ideally hypothesis is a positive form. So we are saying brushing teeth will give less cavities or will make 0 cavities. So that is a positive. If you brush your teeth, then you will not get cavities. So that's a positive statement. And hypothesis should be formed ideally before collecting data, but after doing the literature study. So that is also very important. So usually hypothesis is a very creative task. It involves a lot of imagination, thought process and innovation. So the most basic thing is when we do hypothesis formulation, one is we are thinking at it from a context of discovery, that is we need to discover certain things, and another is the context of justification, that is we have certain data. Now with the data we need to justify what we are going to get. We have to have some logic as to what statement we are going to say in the name of our hypothesis. So usually researcher gets interested in forming a hypothesis mostly with their personal reasons. For example, if I am a person who has a lot of teeth cavities, I'll be interested in understanding why this happens. So it could be personal or it could be something that is very commonly happening in my community or something that's happening to somebody close to me. So mostly there should be some kind of passion, some drive also for the researcher, because when you have to make a hypothesis, you have to be invested in that. The researcher has to put a lot of effort into understanding the background, into making a theoretical framework, into reading the literature, finding out the right instruments, all of these. So it is hypothesis is very important in formulating and guiding a study. So which is why it is very important to have a very creative analytical mind to form the hypothesis based on the problem statement. So researchers should also consider that there should be some relationship which is expected between the variables, and the researcher should be able to give some operational definition to the variables, and then review of literature is also very important before doing the hypothesis, before making the hypothesis. So now we are going to see the types of hypothesis. So I already said that brushing teeth will reduce cavities as my hypothesis. Okay. So whatever assumption we are trying to validate is called as this hypothesis. And in that there are broadly two types of hypothesis in a research. Ideally hypothesis means it should be only one thing. But for the scientific research and for the statistical study, which we will do in the next subject, statistics, we'll actually have two types of hypothesis. The first one is the null hypothesis and the next is the alternate hypothesis. So null hypothesis is always, it is actually the basic statement, and what actually happens is, in the null hypothesis we usually say something like there is no difference. That is how a null hypothesis is being said. Null means zero, nil or zero. That is what null means. So which is why, and hypothesis H. So the symbol of null hypothesis H0. Okay. So H0 is the symbol for null hypothesis, and null hypothesis actually is a hypothesis which says that there is no difference. Okay. So coming back to the example of brushing teeth, I'll help you to understand it better. So we'll be taking two sets of audience to understand if actually brushing teeth makes a difference. The first test is the sample which is being tested, and in that sample we'll be asking them to brush their teeth, and we'll be giving them different tasks, like maybe we'll ask them to brush 2 times a day, 3 times a day, or we'll tell them that you have to brush at least for 2 minutes or 5 minutes or 10 minutes, something like that. We'll keep giving different tasks, and then we will examine how this has affected the number of cavities in their teeth. And then there's a control group for which to whom we'll say don't brush your teeth, or maybe maybe people are not interested in not brush their teeth at all, so we'll say okay, you brush just once in a day, just a regular brush once a day. So that could be a control. So we have two types of samples with us. So one is the sample who will be brushing according to what we want, and that is called as a test sample, and the other is a control sample. Okay. So now making the null hypothesis, I already said null hypothesis is a statement which says that there is no difference. So our null hypothesis will be that there is no difference in cavities between the test and between the test sample and the control, test population and the control population. Which means, so when we saying that there is no difference, which means we are going to look at the mean value. So if there are 10 people in the test group and there are 10 people in the control group, so we'll say that we won't see a difference between these two groups. And to find difference between the two groups, what we do is we calculate the mean value. Okay, so the mean value of test group and mean value of control group is similar, or that is the mathematical statement, or in the as a theoretical statement we say that there is no difference between the two population means. So this is what is known as our null hypothesis. So during experimentation what we do is, so we ask the test group to do brushing, and then there is the control group. We'll calculate the number of cavities that happens in both the groups, and then we'll see what is the mean value of the test group. We'll see what is the mean value of the control group. So if the test group has, say, after brushing, if we find that they have 2 cavities, that is the mean value. And in the control group, even without brushing, we again see 2 values. Then we see that there is not much difference between the 2 groups, which means that the null hypothesis is valid, which means that, you know, there is no difference between the two things. So we'll have to reject, and then we'll go back to the original hypothesis. That's not valid. So we are rejecting the hypothesis which says there's no difference between the 2 groups, which means that brushing doesn't make a difference in the number of cavities. But assume that we are seeing that in the test group after brushing they have only 1 cavity, and the control group have 8. So that's a huge difference. That is really high. So in that case, we will reject the null hypothesis, and this rejection of null hypothesis means we will need an alternative hypothesis to look to. And this alternative hypothesis is the second type of hypothesis, and it is symbolized as HA, A for alternate, or H1, that is alternate to H0. So that is how we have the alternate hypothesis. So alternate hypothesis is a hypothesis which says that there is difference between the 2 samples. Okay, so it is always important to understand that null hypothesis and alternative hypothesis are two types of the same hypothesis, and the difference are in the way in which they are represented symbolically, mathematically and theoretically. Okay. So null hypothesis and alternative hypothesis are the two types of hypothesis, and this is how you explain these two hypotheses. And now I'm going to go to the errors in testing hypothesis. So I did not see this in any exam question, but I saw this as an assignment question. So hypothesis, you already know, these are the few assumptions with which we start a research. It can be proven to be either correct or wrong. So sometimes if you do the if you regularly do the experiment right, and then we do the data analysis in the right way, then we form the right null hypothesis, and then we are doing the test, then we will be able to arrive at a correct conclusion. Sometimes we may make mistakes at any of these steps, and then there could be errors when we test the hypothesis. So the errors in testing a hypothesis can happen with sampling procedure, that is right from when we made the sample for the test and control groups, we could have done it wrong, or the data collection, the test variables and the control variables, the data collection of the variables could be wrong. The study design, so we might have given them brush one time, brush two time, or the design of the study, that could be wrong. Then we could have used a wrong statistical method to analyze the data, that could be a reason. Or we made a wrong conclusion at the end of the study. All of these can cause errors and then give us a incorrect hypothesis. So type 1 error and type 2 errors are the two common types of errors. This is a standard convention. So whatever statement I am going to say next, that is given in your textbook, and that you have to just learn it as it is and repeat it as it is. That is what is known as type 1 error and type 2 error. There is no particular logic to this. So type 1 error is if you reject a null hypothesis if it is true. So I already said a null hypothesis says there is no difference. If there is no difference, then we will actually, when we see that there is no difference, then we actually reject it, and then we say that it doesn't make sense. So when the null hypothesis is true and still if we reject it, that is a type 1 error. And accepting a null hypothesis when it is false, that is called as type 2 error. Okay. So next we are going to the very important topic of sampling. Okay. Sampling means it is a process by which certain units are selected from a population of interest, so that when we study these selected units, whatever results we get, that can be applied to the whole population. That is, if we need to study a community, we may not be able to, for example, you are going to study the female community in India. It is not possible to go and do the study with every female community in India. So what you do is, you take a small sample who is approachable, it is easier for you to reach them. It's not just about easiness. We also need to make sure that they represent the sample in the right way, and then we do the study. All the surveys, the population survey data that happens, this is also happening in that way only. So that is what is sampling. And in sampling, we have certain definitions given. So sampling is a miniature picture of the cross section of the entire group of population, and then we have other definitions also. And in sampling there are few terms used, and these have been asked in the exam. So population refers to the total number of all units that is that has a particular characteristic. So when I say women in India, so all the women in India, all of the women who exist in India, irrespective of their age, irrespective of where they stay, everything, all the women in India, they all form the population. So it is a well-defined set of all elements pertaining to a given characteristic. So the well definition is all the women in India, and all the elements is all the women, and the given characteristic is that they have to be women. Okay. So population is also called as universe. So population can be finite or infinite. So when I say school teachers in Trivandrum. That is finite. To some extent, you can take the numbers. You can just take the number of schools, and in each school there already is a list of number of teachers. So it's easy to understand. It can be counted. But if you're saying all the women in India, that's a huge number. So that is an infinite population. Sample means the single unit that you're selecting is a number of persons selected to represent the population according to some plan. Sample size is the number of individuals selected. For example, if I have to study all the Indian women, or maybe if I have to study all the people of Kerala, there are 3 crore people in Kerala, but I am not going to look at 3 crore. Instead, I am just going to study 3,000 people. So 3,000 is the sample size. It's usually denoted by the number n. Sampling design or strategy. That is the way the researcher selects the samples to be part of their study. What all techniques the researcher employs, what all methods, what all logic the researcher employs, that is known as a sampling design or strategy. Sampling unit means each element that is a sample. So when I said 3,000 people in all of Kerala, each person is a sampling unit. Sampling frame is the list of people from which the sample is taken. For example, the electoral list, the voter list, the telephone book, all these are big lists. So sampling is done because we will get maximum information with minimum cost and maximum reliability, and also it assures maximum precision within the given time frame. And also, if we know the right sampling design and strategy, we could avoid bias in the sample. So the bias definitely can be avoided by randomly selecting the sample, and also ensuring that these are not taken just out of convenience. So now we are talking about the sampling methods. So we told what a sample is, we learned certain terms in sampling, and we understood that there is some certain strategy. If I have to take 3,000 people out of Kerala to study the entire 3 crore population, I'm not going to find the first 3,000 people that are staying close to my house. That is not the right way to study. So for example, if I stay in Ernakulam, I'm staying in the coastal area of Ernakulam, then I'll miss out the people who are staying in the hill regions of Ernakulam. Or if I am staying in a rural area, then if I am just going to look for people around me only to do the study, then I'll miss the people who are staying in tribal area, who are staying in urban area, who are staying in slum area, all of this. So my study, my sampling should always be representative of the population. It should represent all the population. If I take 3,000 people, it should give me an idea about all the 3 crore people. So that is how I should be doing the sampling. So this is known as sampling methods. The right way of deciding who my sample is known as the sample design or strategy, and the process by which I take them is known as the sampling methods. So there are 2 types of sampling methods. One is probability sampling method and other is non-probability sampling method. So probability means, for example, if I am taking a coin and tossing it, I can get either head or tail. There are 2 probabilities, there are 2 options. So probability sampling means there is some randomness. So I am assured that there is some randomness in the kind of audience that I am taking. I am not taking one same kind of audience. So in non-probability sampling, it means that I might end up taking the same kind of audience. I am not bringing in the randomness. I am not putting a sampling design or strategy to bring in the randomness. So we are going to see non-probability sampling methods. It includes haphazard or accident or convenience sampling, quota sampling, purposive sampling, snowball sampling, and systematic sampling. And the probability sampling methods include simple random sampling, stratified sampling, and cluster sampling. So the non-probability sampling methods, in this there is no way of assessing probability of the element that is being, probability of the sample units that are being selected. So in other words, we have no idea, there is no basis to estimate how much the characteristics of each person in the sample may be similar to each other. So we are not using any techniques of random sampling in non-probability sampling method. So the different types of non-probability sampling method, the first one is haphazard, accidental or convenience sampling. Haphazard sampling means what I usually would do is, in case of a haphazard sampling, I'll just take something that is very quick, easy, convenient method. It is mostly it will be ineffective and it is very less likely to be representative of the actual population. Therefore, it is not recommended. It is usually seen in cases of TV interviews where somebody stands on the road. They just find people on the road and they just ask a certain question. For example, someone is walking on the road and they ask them, which party did you vote, or which party do you want to win in the elections? That is a very random way of asking, because maybe if you're going in the afternoon time, you will see only school students. If you're going to during the weekend, you will see families. If you're going in the evening time, maybe you will see people who are more educated or who are reading more paper. Or if you're going early in the morning and then asking, you may see more people who are reading the newspaper and discussing and maybe more well aware about it. Or if you go to a college, or if you go to a high court, you will find a different audience. So different audiences will give different kind of responses to the same question. So haphazard is a random, it's a very not random, sorry, random is a very wrong word to use here. Definitely don't use it, unlike common English term. In research method, different terms have a very strong definite meaning. So haphazard sampling is a quick and cheap method where there could be systematic errors and it is highly unrepresentative of the population and can misrepresent the population. Okay, so next is in the same group itself is accidental or convenience sampling. That is, we are taking the sample just because of my convenience. Like I said, if I have to interview 3,000 people in Kerala, I'm just going to go to the place that I stay. I'm just going to go to the houses near my house and just complete 3,000 people. That is convenience. I'm doing it out of my convenience so that I don't have to travel far. So it is an accidental or convenience sampling. Next is quota sampling. Quota sampling is a slightly better method because we have certain quotas, or we define certain categories of people, and then only we do the sampling. For example, if I want to do a study and then I am saying that, okay, what I'll do is, instead of just randomly going to the 3,000 people, I'll make sure that my population has 50% male, 50% female. So I ensure that. So in the 3,000 population, 1,500 will definitely be male, 1,500 will be definitely female. So if I don't get 1,500 males near my house, so I'll also go outside my community area, I'll go to another area. So it is slightly more representative. And also I'll make sure that I have different age groups. So I'm saying, okay, my questions will be to people, if I'm going with adults only, my questions will be to, and there will be 50% of people who are below 45, 50% of people above 45 years. So I'll ensure that there is some kind of representation, some kind of division of the whole sample. And maybe if I don't get these people within my convenience area, I will have to go outside. So that could be more representative. But this also is not highly representative, but this is more convenient, less costly and more practical to do. So a lot of times people go for quota sampling. Next is purposive sampling. So it is a valuable kind of sampling in special situations. That is, it depends on the researcher and what specific purpose the researcher has to do the sampling. For example, if a researcher wants to study a certain issue with children, then they are not going to go to all children. They will be listing some few issues, some neurological issues that children have, and they may just connect to all the special education centers, and they'll see which all centers have the list of neurological issues that they have listed, and then they may go and do the study only with those audience. So they will be the sample size. So in that case, there is a purpose that the researcher has in mind, and based on that, the researcher is deciding the sample. So this is more appropriate, especially when you have to study certain case studies, when you have to identify certain specific issues. So it is also less costly, more readily accessible, more convenient, and definitely includes only individuals which are relevant to the research. So sometimes it may not truly represent the population, but still it is very useful and valuable because specifically, for example, if I am trying to understand certain neurological diseases in children, then I have a specific access to these categories, and then I can study this in detail, and that can be used in future for any child who has a neurological disease, and then I can use this study. So next method is snowball sampling. So this snowball sampling individually also has been asked as a question multiple times. So snowball sampling is also called as network or referral or reputation sampling. So for example, what happens is, if I need to collect data but I don't know who is the right person to approach. So for example, I want to collect the data of people who use ink pens. So I don't know who all will be using ink pen. So what I'll do is, I know a shopkeeper who sells ink pens. So I tell them, can you help me connect? So he will help me connect to few people. Then so those are students in a school where you are supposed to write only with ink pens. Then I tell them, okay, when you complete your test survey, at the end of it, I'll ask them, please give me contacts of other people who use ink pen. So then they give me. So it is only through referral or through contact or the network of one person to other person, some chain like thing, and that is how I'm selecting the sample. So that is known as a snowball sampling. So the name snowball came because it's like, imagine a small ball of snow on top of a mountain. When it keeps rolling from there, it will collect all the snow around it, and then it will become bigger in size. So this way my sample size becomes bigger with the connection of the people that I'm interviewing first. So there is an issue here that sometimes when we do the snowball sampling, it can actually become difficult and very time consuming process if I need a very big sample size. And also sometimes it could not give me right statistical study, because sometimes it's not, the sample members are not randomly drawn, but it is depending on the first few people that I chose. It's only from their network that I'll get. So it's not again a very random way, but still it is a much easier way of getting the right kind of audience. Next is systematic sampling. Though systematic sampling is a non-probability or a non-random method, it has similarity to the probability or the random method of sampling. So also the name systematic also makes it slightly confusing. So you have to remember, systematic sampling is part of non-probability sampling. So systematic sampling includes where we give a certain definition to how we will do the sampling. So in a class of say 100 students, what I'll be saying is every 10th student will be taken as a sample. So when I'm saying all the 100 students, what I'll do is I'll just take number 10, number 20, number 30 and so on till 100. So I'll take just 10 students out of that. So that is known as a systematic sampling. So it is also a very important method because it's a fast way of obtaining samples, and it is easy to use. You don't need to have a lot of knowledge to employ this method. So next is the probability sampling methods or the random sampling methods. So we have a specific way in which we know that how a certain person will be selected in the sample. Therefore, there is no bias, and this reduces the sampling errors and helps to give a better efficiency and better accuracy in the test studies that we are doing. And therefore this can also be easily generalized to the entire population. So here what I'll be doing is, if I have to take 3000 people from Kerala, I'll make sure, okay, my 50% of population is male, 50% is female. Then I'll see how Kerala is. So if there is equal amount of coastal, equal amount of tribal, rural, urban, slum population, then I'll be like, okay, 5 different types. So in this 3000, it should only be 600 people from each group. And in the 600, it should be 300 male, 300 female. And in that also, if I'm assuming I'm doing study only for adults, then I'll say out of that, 50% should be people above 45 years, 50% should be people below 45 years. So I'm giving a lot of description to how I'll select the sample, and from that I'll be taking the sample. So that is how I define a probability sampling. The first method is simple random sampling. So in a simple random sampling, what happens is I'll have all the entire list of people, and there is equal chance for all the people to be selected. And the selection process is such that if I select one out of it, it does not decide how the next person will be selected. Okay, for example, if I have to take 3000 people out of 3 crore people in Kerala, what I should do is I should have a list of all the 3 crore people, all the names of all 3 crore people, and then I have to blindfold and randomly pick 3000 people. So when you hear it itself, it sounds very confusing. How can we do it? Yes, it is very difficult when it is a big number. So we won't do simple random sampling for big numbers. Instead, we do it for smaller numbers. So the earlier case where I said a class of 100 students, if I need to take 10 students, what I'll do is I'll write down the name of all 100 students on single piece of paper, fold it, keep it in a bowl, and then I'll just fold my eyes, then take 10 out of it. So then all the 10 numbers had equal chance of being picked. It's a very random way of picking, and if I pick one, it doesn't mean that the next will be picked or will not be picked. Anybody can be picked next. So that is simple random sampling. So simple random sampling is a very effective way, and it is the advantages are that all members have equal chance. So this is a method against with other methods are compared and evaluated. It is very suitable when the population is small and the sampling frame, that is the total list of people, are up to date. So when the sample size increases, then it becomes difficult. It's very cheap method and easily accessible. And there are some disadvantages, that is always we need an up-to-date list of people. Large sample size becomes difficult. If it has to be done across a larger geographical area also, it becomes difficult. And the person who does this should be skilled enough so that they don't make mistakes while doing this process. Next is stratified random sampling. Stratified random sampling, as the term means, it includes the word strata or stratified, which means creating layers and then doing the random sampling. So when we say stratified or creating layers, the population that we have is divided into different layers. So like what I said earlier, when I have to take 3000 people out of Kerala, I'll divide it into layers. Okay. First layer will be on one criteria like sex. Okay. So one criteria, male and female. My one criteria is sex, and in the sex criteria I have two options, male and female. So that gives me a 2 strata combination. And onto it, I am adding another layer or another strata to it. I'll be saying the age as a factor. So above 45 and below 45. So I'll have 4 strata. That is, my first group will be males who are above 45. My second group will be females who are above 45. My third group will be males below 45. My fourth group will be females below 45. So I'll have 4 strata. So then I have to make sure that I'm taking my population from this number. So it will not be all 3000 from the same place. But what I'll do is, it will be divided. My 3000 number will be divided into 4 equal parts, and I'll ensure that I'll take only equal number from all these 4 divisions. So we have an assumption that all these strata will be uniform within each strata, that is homogeneous internally, and therefore we can just do a random sampling after this process. So there can be many reasons as to why we are using stratification in a population. Stratification tends to increase the precision in estimating the characteristics of the population. Also, stratification helps to give us some convenience in the kind of sampling that we are doing. So when there are multiple units, so different people can be assigned to different units and it will be easier to complete the sampling process. So specific advantages of stratified random sampling are: one, it is more representative of the population because we are making different layers of strata, and then we are further taking a random sample out of each of these. So two, it is precise and therefore it can avoid bias. It saves time and the cost of data collection. The disadvantages are that if the stratification is not correct or if it is improper, our results can be wrong. If there are different geographical areas to be reached out to, then it can be more time consuming, it could be more cost consuming, and definitely there should be skilled people to do the stratification. The third way of probability sampling method is cluster sampling. So this is also a modification on the random sampling method, but here we make clusters or units in different stages. In the stratified one, we made different layers. Here we are making in different stages. That is, for example, if we have to identify the vocabulary of class 3 students in India, what we'll do is I cannot just go to a school that is next to me and then do the study and then say that it represents all of India. So what I'll do is I'll divide India into the different states. So there are 29 states, and so I'll say that, okay, I'll be picking randomly. I'll say I'll pick 5 states out of these 29 states. And in these 5 states, I'll see number of districts that are there in all these states. And I'll make a list of the districts, and out of that, I'll pick randomly again 5 districts in it. And in each of the selected districts, so I've got already 25 districts, 5 states, 5 districts each, so 25 districts. Now what I'll do is I'll again list all the schools in each district, and again I'll pick 5 schools out of each district. And that out of these schools that I've chosen, I'll go to the class 3 students, and then I'll do the study. Then I'll try to find out how many of the vocabulary of the students. So that will be representative of the whole Indian population. So this sampling method is known as cluster sampling, because I have made clusters. In the first stage, I made clusters of the states. Next stage, I made clusters of the districts. Then I made clusters of the schools, and then only I chose my characteristic population, which is class 3 students. So here at each level, the random sampling is happening. So the final sample also becomes random, and this is also known as cluster sampling or multi-stage sampling, and it is more flexible than other methods. This is less accurate than a single stage sample, because there could be some errors when we do multiple stages, but otherwise this is also very good method to reach large geographical areas, and this is definitely less time consuming and less cost consuming. So now we know what all are the different types of sampling, what all are the different terms in sampling, and we also need to know why sampling is important. Sampling actually helps to understand how we can generalize the data by doing the experiment on a smaller group. So it is a very important part. So with this, we come to the end of unit 4. So which means we are ending the first block of research methods. After this, we'll go to the second block of research method. Totally there are 4 blocks. So we have completed the first block of research methods and specifically focused on the topics which have been repeatedly coming for exam.